Welcome to our video tutorial here on hyperbolas. We are going to work with this single equation of a hyperbola. We're going to graph the hyperbola with all of its key features noted, and we're going to see if we can agree on what that graph looks like. Perhaps you want to hit pause and try this problem out before we proceed together. The first thing that we should all be capable of doing is identifying the center point for the hyperbola. It'll be at 6, negative 2. Now remember, when we have a hyperbola equation, there should always be an equals 1. That's key, that's essential. The other thing is we should have x and y being squared. We have x and y being squared in this problem. The other item that's key to a hyperbola is that you're subtracting the values of x and y. In this case, the y is negative. Sometimes the x will be negative. How we determine whether it's a vertical or horizontal hyperbola comes down to which of the variables is positive. In this problem, it's the x term that has the positive coefficient. Therefore, this will be a horizontal hyperbola. When we go to determine how far left and right the hyperbola goes from the center point, we take the square root of whatever the denominator is with the x term. In this case, 4. When we go to determine how far vertically it goes from the center point, we take the square root of the denominator from the y term. In this case, that would be 5. And when we go to determine the focal point for a hyperbola is the typical way that we look at the Pythagorean theorem. C squared is equal to a squared plus b squared. In this case, c squared would be equal to 16 plus 25. As we discussed in class, we really don't decipher what is a and what is b. So c squared is going to be 41, or c would be plus or minus radical 41. So when we go to sketch this graph, we're going to start with the center point at 6, negative 2. Now we're not going to draw the graphs perfectly to scale, in the sense that you don't have to have grid lines and all those other key features. So what we're going to do is just draw in the asymptotes like that, draw in the other asymptote like this. That's not going to be too terribly specific. It's a horizontal hyperbola. So we go 4 to the left. That will put us at 2, negative 2. And that's going to be one of the endpoints, if we want to call it that, of our hyperbola. We will draw it in like so. We go right 4, and that'll put us at 10, negative 2. And that will be the other so-called endpoint, or just key point, for our hyperbola. These are asymptotes. So it should look like your hyperbola gets really close to the asymptote but doesn't actually cross it. Next, focal points. The focal points are square root of 41 away from the center point. So here we would have 6 plus radical 41, negative 2. Going back to the left, we would have 6 minus radical 41, negative 2. Now when we look at this adding 5 over here, it's really not anything that's really on our graph. So we would have the point 6, 3. Down below we would have the point 6, negative 7. But those are not points that you're going to have to label on our picture. The other thing that needs labeled on our picture would be the equations of our asymptotes. Now, as we saw in class, we're looking at the denominator from y and the denominator from x, but we're really looking at their square roots. So the slopes of these lines respectively should be that this line is going to have a slope of positive 5/4. Take the denominator from the y, take the denominator from the x, and kind of work with it in that direction. And the slope for the line going downwards would be a negative 5/4. We know that it's also going through the center point of 6, negative 2, so we could plug into y minus y1 equals m times x minus x1. Now, if I simply said to write an equation for the asymptote, what we just boxed in would be fine. But if I specify that I want the slope-intercept form, then we would have to go through and distribute our 5/4. 5/4 times a negative 6. We'll get negative 15 halves. And on this one we would have y, don't forget your x actually, equals 5/4 x minus 19 halves. That would be the equation of our asymptote that's going upwards. Please make sure it's clear what's what. And then for our other asymptote, it also has a slope of negative 5/4. It's also going through the center point of 6 comma negative 2. We would plug into y minus y1 equals m times x minus x1. If we were specified to have slope-intercept form for our final answer, we would have, let's make sure we put the x there, y is equal to a negative 5/4 x plus 11 halves. That would be our asymptote that's sloping downhill. Please make sure it's clearly labeled. Just have them by where they belong in the picture. So this asymptote going downhill is y equals negative 5/4 x plus 11 halves. The one going uphill is y equals 5/4 x minus 19 halves. That is really how we get our hyperbola. And it's really not all that bad. Sure, there could be some twists on it. Sure, there could be little intricacies here and there. But keep everything in mind, and keep in mind that the focal point is the furthest out thing, so that's why the c squared, in this case, is equal to a squared plus b squared.